So we want to discuss some examples. As we saw in the previous table, we can take antiderivative of this function by taking antiderivative of each term one by one. So antiderivative of this is going to be antiderivative of first term. Well, the power will increase by 1, so it's going to be 10. But to take care of this 10, we need 1/10. Then when you take derivative, we will have canceling to get back to x to the 9th. And scalar multiple of, so antiderivative of scalar multiple is scalar multiple of the antiderivative, minus. New power is 7. That's why we need 1/7. And this coefficient will survive like that. And then x to the 4th power, we need 1/4 to get rid of this 4 when you take derivative. And this number 10 will survive. Sine guy has an antiderivative, negative cosine. So we haven't considered the constant c. Well, we have constant for each term, but you add them up to get universal c. So that is good enough. So this c will take care of infinitely many antiderivatives of this function. Number 2. Well, we can start with rewriting a little bit. So this function becomes, first guy is t to the some power. We have square root in the denominator. That's why we need new power, negative 1/2, plus t to the 1 plus, well, we have t to the 1 times t to the half. So t to the 3/2. And we take antiderivative of those terms one by one. So antiderivative is going to be antiderivative of first, t to the power will increase by 1. So it's going to be 1/2. Eventually, you want to take care of that. So you want to put 1 over this, like this. Then once you take derivative, this 1/2 will be gotten rid of, and so you will get back to negative 1/2. And these two will survive. That. And copy of t will give you t squared. And then new power is 3/2 plus 1. 5/2, 1 over this power, 3 over 2, plus constant. And you may want to rewrite a little bit. This guy is 2 times 2. And then copy of t squared. And then, well, you can flip this, 2/3 t to the 5 over 2. Oh, this should be 5/2. So this should be 5/2. So this 5/2 will get rid of this 5/2 when you take derivative. So this will get back to 3/2. When you flip, we have 2 over 5 plus constant c. Okay, so number 3 looks complicated, but once you split into pieces, it's going to be quite similar to number 2. So when you split, the first term is x to the 5th over x to the 4th. So x to the 1. Second term is x to the 3rd over x to the 4th. And then 6x over x to the 4th. And 5x to the half over x to the 4th. Well, we need half minus 4 is negative 7 helps. That's what we need. Good. And then you take antiderivative of each term. So capital F is going to be antiderivative of this. And then, well, this is 1 over x. That's why we need ln plus 6 will survive. New power is negative 3 plus 1. Then you take 1 over this new power plus x to the negative 7 helps plus 1. And then 1 over this is 2 over 5. And then this 5 will survive. We need negative. Negative? Yep. Good. And then once you take derivative, you will get back to 5 x to the negative 7 helps plus c.